So our next topic is going to be AI in aviation. So we're going to be having a fireside chat, and we're going to be having our two speakers on the dais. One is going to be CP Jois. A few words about the speaker. CP Jois, the founder of Aero, is a multifaceted professional with a profound passion for aviation. As a pilot and an assistant professor of aeronautics at Embry-Riddle Aeronautical University, he combines practical experience with academic insight to educate and inspire the next generation of aviation enthusiasts and professionals. And our other speaker is going to be Divya Manchanda, who's the chief of Airworthiness and head of operation E-Plane AI, who's going to be the moderator for the session. She's a leader in aviation technology with a focus on safety and efficiency. She oversees airworthiness standards and operational excellence. Manchanda's expertise drives E-Plane AI in revolutionizing the aviation industry with innovative solutions for enhanced safety and performance. So can we all put our hands together to welcome for the fireside chat with Divya Manchanda being the moderator and CP Jois joining us on the other side. Can we have a huge round of applause to welcome them both onto the dais, please? A very warm welcome to both of you. Kindly request you to make yourself comfortable. And the stage is all yours.
Am I audible?
Hello.
Great. All right. Good evening, everyone, and welcome to this fireside chat session on AI in aviation. And welcome back to India, CP.
Thank you.
Or rather, I should say, welcome back to land. You finally landed. So a little bit about CP is that, half the time he's up in the air. He's either traveling on business assignments, or he is flying charter airplanes, or he is doing recreational flying. And when he is not up in the air and he's on the ground, he is teaching people how to design, how to fly aircraft. He is also building his own simulators in the basement of his house. He has, and on top of all of this, he just happens to be the CTO and the CIO for the last 30 years. So a very, very vast background, and I think I'm quite excited about this discussion, learning much about how AI can be leveraged in aviation from him. So thank you, CP. Thank you for joining us.
Thank you. Firstly, it's always wonderful to be talking to another aviator. So that's I deem that an honor. And thanks for having me here. I flew in yesterday night, completely excited to be a part of this. So thank you.
Yeah, he is a bit jet lagged.
Indeed, I am. So I guess when you're passionate about aviation, you can't complain about jet lag anymore. So.
Yeah. I completely understand where you're coming from. And even though his name is CP Jois, I have decided to call him Charlie Papa, as we call it in aviation. These are the terminologies. And I have known Charlie Papa for all of, I think, more than an hour. And aviation kind of attracts you and pulls you into, just being connected and wanting to know more. So it just feels like I've known him for a long time.
Thank you.
Okay, so why are we having this topic of AI in aviation? So when we think about the word AI, a couple of things come into your mind, and probably in the audience, if I just throw out the word artificial intelligence, just tell me what are the words that come to your mind? Anybody, anything? Anyone? Have you all heard about artificial intelligence? Yes, I see a lot of nods. So what is that one thing that comes to your mind? Any word? Innovation, automation, data sets, algorithms, correct, and big data, precision algorithms, language processing models, etc., right? And when we talk about aviation, okay, that's an easy one. Does anybody want to come up with any words that come to your mind? Pilots, aircraft, airport, correct, and cabin crew, and all of these airport operations, ATCs, right? So what happens when you combine both of them, and what is the need of artificial intelligence in aviation? Now, back in the days, aviation was all about, few number of flights. You started off with Indian Airlines, which was called Vayodut, and slowly, gradually, you have a lot of flights. And as on today in India, we have 6,000 flights every day. The number of ATC controllers that are controlling this are just 4,000. And as we move along, the volumes in the air are only going to increase and increase massively, because the amount of domestic and international travel that is going to happen from India is tremendous. So how are you going to handle all of this, right? And that is where AI is going to come into aviation. And now I'm going to throw this thing to Charlie Papa, and I'm going to ask him that AI entered aviation a long time ago, but what do you think has been the adoption of AI in aviation? Has it been great? Has it been very restrictive? What are your opinion?
I think there are some fundamental differences to think through. Number one, indeed, intelligence entered aviation a long time ago. It dates back to the early 30s. We're not even talking a decade or 2 decades ago. But intelligence is a very nuanced term. It's got several definitions when you talk about intelligence. What we describe as AI today, when you go back in history, you would talk about intelligence. The first thing that comes to most people's minds would be the autopilot, right? But we had radio navigation, we have had flight management computers, we have had the autopilot systems, we have instrument landing systems that land your airplanes to a point. And there are several versions of intelligence within the aircraft. But outside the aircraft, I used to work for United Airlines, and we ran crew pairing algorithms for a month before we could create a roster for the entire month in a global airline. Flight planning, intelligence in flight planning, flight trajectory, flight routing, fuel planning, cargo balancing, calculating weight and balance in airplanes. I think intelligence took many forms and was always present, and therefore adoption almost began with the maturity of the technology and the ability to implement it. But what we talk about AI today is somewhat nuanced and very different, and I'll tell you what the distinction is. All the things that I just spoke about in terms of intelligence in the years that have gone by, historically, have been programmed into the airplane, into a system, into the operation, air traffic management, for example, right? We wrote the rules, we knew it worked for the human, so we programmed it, and programmatically we ran the operation. So that was the intelligence we distilled in our heads, and we plugged it in through programmatic character. What we expect AI to do or machine learning to do today is somewhat different. And that, I think, is a fundamental difference between what has happened and what is happening today. We expect the software, the program, to learn on its own the rules that we initially were feeding it, hoping that it will be better than what it used to be before. So we give it a data set, and we allow for it to watch for patterns and distill the patterns out, and that's what it uses to run. Therefore, we are not intervening as humans anymore. Secondly, we believe that it can get better with every passing iteration. So every day, we expect it will learn and therefore make itself better. That is the difference between what we adopted for the past 70 years and what is now coming up on the anvil for aviation or for any other industry to adopt. The ability to learn from data what we're observing, and the ability to apply it and iterate through it and get better with every passing day. I don't think that has ever happened. So adoption has always been rapid because it's driven by need. But I think what we're talking about today is somewhat beyond what we have done in the past.
Right. But when we're talking about data sets and being able to process large amounts of data sets and kind of do predictive analysis on it. Do you think that it has largely been restricted only at the aircraft level? Because you come from experience of having worked in a number of airlines and in a different verticals like flight operations, ground operations. So for instance, I'll tell you, way back in my journey in Jet Airways, one of the key things that we wanted AI, or rather machine learning in the beginning, to come in was disaster management. And disaster management, I don't mean that an aircraft has just gone down and crashed. Disaster management is that today the weather is not doing good, and now the flights have to be diverted. And a lot of people may not know this, but there is a lot of commotion that goes on behind when a flight has to be diverted. So there are multiple people who need to come into the picture and work together with each other to make that one diversion happen, and that has cost implications also. Because now, the customer is going to come back and say, hey, pay me back for my flight, etc., etc. So there are a lot of departments that come in. So when we talk about these verticals in the organizations, do you think they have adopted AI fairly well?
That's a very good question. In fact, in my opinion, it's far more easier, and it has been far more possible for the other departments to adopt technology. And I'll stop short of AI because of the distinction I just brought up, but use technology to operate all of those functions. For example, irregular operations as you define it in a crisis. And I live in Chicago, so there is a weather crisis almost every winter. It's a common thing out there. And so when you have to go through irregular operations of any kind, we call it IROps, and then we reroute, we cancel, we divert planes, we end up rebooking passengers. There are ground halts, we reroute aircraft. Then bringing on a global carrier to bring all the planes back to where they needed to be, a failure that Southwest experienced about 2 years ago, and they could not bring all the planes back together, is a fairly common thing. 25 years ago, I had a team that would write mathematical, statistical algorithms and run it on computational power, right? So we were perhaps adopting more of ultimately all AI is statistics based. Just that the human is observing the pattern and programming it into the code rather than allowing the software to absorb its own patterns, basically. But we were doing all that 25 years ago. Airport operations, centralization of skills within the airport, not allocating manpower to every gate or every group of gates, but centralizing the pool, saving costs, especially when we went through the years of 2001 and beyond, when airlines were struggling. We did more of this than ever before. And I think they were more open, and I think it was more feasible to adopt any form of technology, including intelligence in the way we are describing it, in those functions, rather than inside the aircraft, especially on the flight deck. Outside the flight deck, for example, you could apply a lot more AI even today. It's far more easier than to begin to adopt it inside the flight deck, just given the nature of regulatory approvals you need, safety, risk mitigation, acceptance by the passenger, acceptance by the flight crew, the ability to handle a crisis when automation or autonomy is taken away from the pilot. I think in those circumstances, it becomes a little harder to adopt it fast enough, but I think it's a matter of time before it does get adopted. But other functions inside ground operations, cargo operations, flight operations, the network operations center, all of these were always able to, and I think they've done fairly well. For that matter, even before we anticipated a crisis of any kind, the ground rerouting programs, the ground halt programs, the irregular operations algorithms would all begin to run hours before the actual crisis hit. And they were just mathematical algorithms, rebooking passengers, rerouting planes, recovering planes, repositioning planes. Sometimes we were repositioning planes 2 days in advance. And so, yes, they were far, far ahead of the rest of the ecosystem in adopting intelligence as part of their day-to-day operations.
Wow. So do you think that this insight is more from US per se, or is this a trend that you've seen all over the world?
I think it's a trend where there is demand. It's not, I think, geographical at all. As soon as India began to see this upsurge in its economy, as soon as you began to see more airplanes in the sky, As soon as you began to feel the demand on air traffic control, you didn't have this many planes in the sky 25 years ago. You would have 4 scheduled flights going up and down, and my father would travel frequently, and I would know exactly which time what flight took off, and most times they may be delayed, but it was okay. There is not being caused by the number of planes in the sky. Yesterday in Frankfurt, we missed our takeoff slot by 15 minutes, and we were on the ground for an hour and a half because there was only one corridor open, and that corridor was towards the south, and every plane was departing to the south. We just couldn't even get in line. And the other corridors were blocked off because of weather, and we could not use them. It cost us 2 hours just because we couldn't push back, and we had bags to load for about 15 minutes past our departure time. So when demand builds up, I think solutions will be needed, and that's when you begin to adopt it. When you talk of irregular ops, 10 years ago in India, I don't think you'd be thinking of irregular ops. Today, with the load you're talking about, 6,000 planes in the sky, especially over central India, every plane goes to central India. If you see Flight Radar 24, you'll see the beeline of airplanes over the Indian geographical map, and you'll see how much that has changed in historical terms from 10 years ago to today. So as soon as demand shows up, solutions will be needed, and therefore adoption becomes key. That evolution, I think, is more driven by necessity rather than the fact that the technology was available, not available, or computational power is cheap or not so cheap. As soon as you need it, you'll find a solution for it. Airports are small. Today, if you go to Bangalore Airport or Chennai Airport, there are not enough gates there to park planes. They're being parked everywhere around the airport tarmac. So you'll be forced to adopt newer methods of then managing that. So that's, I think, how the evolution happens.
Right. And it's interesting that you brought up the topic of airports and the perfect example, because I think Bangalore Airport is, it's the hub of innovation in India, and it's adopted technology in a massive and a great way, right? It attracts people from all over the world. And they've expanded also in a big way recently. So, but what are the implications of doing too much of AI when it comes to customer or passenger experience, right? So for example, in Bangalore Airport, I'm still, even though I'm a big ardent fan of technology, but when they talk about, doing face recognition to enter the airport, I'm still a bit more skeptical about doing that. So when we're talking about AI coming into, in airport operations and airline operations, how much do you think that this can be adopted by the customer, and where should the line be drawn?
I think as a pilot yourself, I was going to ask you that question myself, in fact. But my perspective is this: there's a fine balance between overdoing something and not using it. And that line is defined by, I think, safety and risk. So where the two lines cross over on a chart, where risk exceeds benefit, is the time you got to stop. Whether that's inside the airplane, outside the airplane, in an airport, outside the airport. We saw incidents with the 737 MAX recently, and a lot of it was taking away the override capability of those pilots within the cockpit and caused an incident. At what point does automation of any kind, AI or non-AI, it doesn't even have to be AI, if you just use routine automation to do something and it fails, what is the risk that you carry with that? To me, personally, once risk exceeds the benefit, then you got to stop implementing it any further. It does take some time to use any technology and make sure it's reliable and repeatable. So right now, if you flow through most of the foreign airports, you'll find international airports are scanning your face, but they're not using it entirely to actually say, I won't look at your passport. They still look at your passport, and they'll also scan your face to make sure that it's doing what it's supposed to do. And that trial may run for the next 20 years before we say it's ready for prime time. Self-driving cars, we talk about it. I mean, they're not ready for prime time. They've been talking about it for 15 years at least now. Someday they may be, maybe they never will be, right? But the risk-benefit ratio is what, to me, guides the acceptance and the adoption of any technology. Once risk exceeds the benefit, I think we're better off not using it at that point in time. Otherwise, you'll see incidents which has two problems. One is the incident is bad enough, it's enough damage, but it also takes away people's confidence in technology itself. A long time after the 737 incidents happened, many people are very wary. Until then, most of the flying population doesn't really want to know what airplane they're flying on. Some of us airplane fanatics may want to know exactly what aircraft you're on. Most of them fly with the extreme confidence that if you're bored, I will be safe and I'll land in time and I'll land safely. They don't want to know the nuances of what engines it's carrying and who's flying and who manufactured the airplane and so on and so forth. But the minute you do this, now everybody's asking, am I flying a MAX? I don't want to fly today. So they started booking flights which were not MAX oriented. So you see that the deterioration in people's confidence, that's where it takes a hit. And to recover the technology is easy, but to regain people's confidence is very hard. So I would always err on the side of safety to say, if I'm going to hurt any confidence anywhere by any standard, then I would rather hold back.
Right. And even when you were coming from the pilot's perspective, the same question, right? I think pilots by design have been trained to, fly the aircraft. And we love to fly the aircraft, right? We love to feel the aircraft and fly the aircraft. But there comes a point where I also know as a pilot that, I not only have to fly the aircraft, but I also have to talk to the ATC. I have to make sure the passengers are doing okay. I have to speak to the cabin crew. I have to look at my next procedure. I need to know what is the weather at the next airport. I have multitude of functions that I need to perform. But the biggest function is what for the pilot? The biggest function is to be able to make decisions. So if my sundry work in the cockpit can be automated and I can be a decision maker, and when you say that, as long as the risk is not taking over safety, then it's all fine, right?
In fact, in cockpits today, you see a lot of technology. Part of the problem today with having too much technology in the cockpit is it can be distracting. And I see this. There are several case studies, especially in general aviation, which is not non-commercial, but it could be commercial. But if you fly smaller planes, there are many pilots who are entirely distracted with having an iPad, a telephone, a smartphone, the GPS unit in the cockpit itself, all the electronics, they're all supplementary. They're all there to help you, assist you with decreasing workload, right? So that you can focus on what's important as a pilot. When that workload begins to increase, and an example I'll give you this, iPads tend to heat very quickly, and they're not certified for primary flight. But as soon as iPad starts to heat, the smartphone becomes your backup, or your multiple GPS units in the cockpit all don't show the exact same information, the lack of coherence, as we say. Now the pilot's gotten busy figuring out why all these things are not matching up, or why this thing is not working, or it's not connecting. I have personally seen this distraction in the cockpit. What that does, now it's quickly taken away from being helpful, assistive devices, to becoming a distraction in the cockpit. Now he or she is not looking outside anymore to fly, or focused on what is truly important, which is to aviate, navigate, and communicate. Now you're focused on all the electronics you're carrying in the cockpit, and more we use. People have watches on them, they have the smartphone, they have the iPads, they have the GTN 750s, they have all these devices. It just takes one distraction to cause an incident. So they're helpful to a point. At some point, it starts to become a distraction.
Right. Okay, so a lot of you may not know that Charlie Papa has, I did mention it in the beginning of the chat that, he's built simulators in the basement of his house. But he started this journey, I think, way back in 1997.
I've been in simulators since I was 17. In 82 okay. was my first experience with simulators.
Right. Okay. So even way back, right? So he's had this very ardent journey, and he's also started his journey as a software engineer, a technologist. He's been very fascinated with electronic boards and things like that. And when he amalgamated all of his learning experience with his love for passion, that's where the simulators were born. And you've spent crazy number of years in building simulators. What do you see as a problem in the current simulators? And how do you think artificial intelligence can be brought in to make simulators better?
I think there are no problems as such with current day simulator. In fact, current day may be a wrong reference, because if you look at it 20 years ago, even 10 years ago, the fidelity, as we use the term in aviation, the fidelity of a simulator is what is most important. A lot of research got done for 40 years between 1950 and 1975, 1980, as to how can we improve fidelity. Questions in research were all about, is fidelity important? Is a motion platform required? Can we learn without it? So these questions were all primary at that point in time. But if anyone who goes back in history in aviation, today's least expensive simulators that anyone can acquire or have access to have far more capabilities than some of the best airline simulators had back in the 70s. Why? Because computational power, computers have gotten so much better, they become cheaper, memory is cheap, storage is cheap, manufacturing these devices have become a lot simpler. So you can buy a basic air training device or an advanced aviation training device for little or no money nowadays. It's not expensive. And so students can afford one or get access to one, given that the level of the quality of simulation has definitely gone up in leaps and bounds. What pilots could not have access to 40, 50 years ago, any youth can have access to today in their own home if they just buy a $49 package. So it's not very hard to do that today. What is essential, though, is to turn them around and make them real aids to cutting cost and cutting time, which has been my primary driver for all the study, the research, the design, the build, and all the hours I put into flight simulation work to see if we can truly cut down the cost of training. Many students depart aviation because they can't afford it. It's very, very expensive. You know this personally. And it's very expensive. Many people drop out. You need to fly every day when you're training. Otherwise, you lose muscle memory. It takes you 2 years to get there. And finally, you'll give up because you run out of cash at the time. So my goal was to see if we could improve that situation. In the process of that, yes, I prototyped multiple generations of simulators from small to large. And what I find to be most useful is regulatory change. I think that has to change. Simulators are more than capable today to train a student from 0 to 60 to get his or her license completely. Will regulations accept it? Perhaps not today. And therefore, that's one thing that needs to shift. But when it comes to AI or learning management within inside a simulator, the capability exists within simulators today to advance the notion of realistic, real-time, adaptive simulation. It's not a one-size-fits-all for you and I. If you're learning a certain way, it begins to build the intensity of simulation on you differently than it would do for me. On the other side, when pilots go back in for recurrent training, you can observe and notice over a period of time if my skills are degrading. If I am degrading my skills, in many accident studies, you'll find that a person was already making those mistakes in the simulator. We let it go, and then it happened in the real world and caused a damage, right? So can we observe that and keep records of it to really focus on what's needed for that individual and not have a one-size-fits-all type model? Personally, I think that's the best spot for AI and learning management to work, customizing training to the needs of the individual. So it's never going to be a one-size-fits-all. It's never going to be training the same person, every person on the same things constantly. Beyond that, what I'm right now focused on is to be able to tap into a simulator, drill a hole in the simulator data stream, tap into the data, pull out the data, apply machine learning to it, and learn what exactly a student pilot or a recurrent training pilot is doing, and use that to feed back the loop to advance the nature of what training I'm providing you. The patterns that are showing up are far more granular, higher resolution in terms of data, that I can know more about you through observing your data stream than an examiner sitting next to you watching you fly. There's only so much a human eye can comprehend. We'll know that you have either done well or not done well. How well you did, how many changes did you have to make? For example, on a landing, if you landed perfectly in a straight line, they'll say you pass. Now, did you do it with ease or did you do it with difficulty? That only a machine can tell you. Because the examiner is only saying, well, did you complete or not complete? I think you're okay. But the machine can tell you a little bit more than the examiner is watching you do. So to me right now, that's the largest power, and computational power exists today to process that level of data, which we didn't have 40 years ago. So if there's opportunity in the world of simulation, it is exactly that, tapping into the data stream in real time to customize training as we provide it to you, to focus on the very weaknesses that you're showing or demonstrating, and not just training on something you've already done well.
Yeah, I think that's a brilliant point that you've touched upon, because while you were talking, it was taking me back to my training days in the simulator, and I was just wondering, one of the key things that always came, actually a couple of things. One was, the trainer always like coming and telling you that, hey, you did this the last time, okay, let me look it up, and you're repeating this mistake again. I would want that. as a pilot. I would want that, I'm corrected and all those things. So if all of that can be modeled from your history and told to me well in advance, it can better the pilots. It can also help the trainers in formulating better training programs. The other thing that I think the simulators, in my opinion, lacked were that it's not a very realistic environment to fly in, right? Because when we would take off in the simulator, and let's say you're doing a visual pattern is not really very realistic. One of the points that one would really struggle with when you would actually get into the real aircraft. The second thing is the weather. So let's say if I have to simulate weather in the simulator, if you have to show fog is not consistent everywhere, right? So it's a bit light and then it becomes deeper, and the way you see and feel fog in the aircraft is very different. The third thing is in your landings, the G-force, it's all very artificial, but the actual G-forces, the actual effect of the crosswinds, etc., they're extremely different, right, from a pilot's perspective, and I think you will second that. So how do you think that artificial intelligence can help in those regards?
I think today that has changed even without AI. The ability for graphical power units, the GPUs that run graphics on a machine have come leaps and bounds. NVIDIA, like companies, have done fascinating work. And so you see the cards exist, the power exists, the computational power exists. So you're able to generate shaders of all kinds. Weather simulation on a simulator exceeds anything. High resolution displays can demonstrate fog in so many gradation levels that you can't even tell the difference between real world fog and simulator fog. Precipitation, rain, snow, winds, crosswinds, shears, wind shears in the air, all of that modeling is done really well. The presentation of that is where AI can help, though, because it can't be just random, right? We used to force an event in simulators before. You don't need to do that today. It really can do it at the time when it's most needed. And weather modeling, by drawing weather data from aviation weather sources, is almost near precise. The challenge, I think, even back then, was not that the technology was not there to present weather in a realistic way. The computational capability was not there for it to power through all of that. So instead of slowing down the simulation, you would see stuttering simulators otherwise. Instead of that, you would lessen the load, thereby degrade the visual, but let it flow seamlessly to the pilot in training, right? Today, you can have both. Have good performance and yet high resolution, and present it on LED displays, and you won't tell the difference. So all that's there. But the moment it's to be presented has to be guided by what I told you before. Present it to the student at the point that the trainee will feel it the most. Where were they going wrong the last time? On an emergency procedure in a takeoff, if you do an engine shutdown or a flame out on an engine, you really want to present it at the time when you found them to be the weakest. So that presentation needs to be AI enabled, right? Only then that intelligence carries through. The other thing research has shown is with age, complacency builds in. You believe you're a good driver because you've driven so many years. You see a number of pilots who have 20,000 hours of flying time make a mistake. In a small plane sometimes, flying recreationally. How can that be? People ask. It does happen. You get overconfident. You believe, I can power through this. I've done it for so many years. So complacency builds in, or bad habits come through. If Tiger Woods as a golfer needs to unlearn his swing and relearn his swing multiple times in his golf career, you need to ensure that you have to be able to retrain pilots to come back and learn their flying multiple times over.
Sure, thanks. And I would like to throw some questions to the audience over here. If anybody has anything. Oh, great, that was a quick one.
Thank you. It was great listening to you both. And then I actually had a question, but you answered it really well. So it's going to be a comment more than a question. So I was thinking when AI is coming in, or for that matter, any technology is coming in, should we even jump into it and then see what it is going to offer for an aviation industry? Because it's very scary for a flight. And you also touched upon 737 MAX. So when an MCAS system, it is only a sensor which was not working, and it was very terrible results. So the question was should we even jump into this because we have a new technology and you answered it really, really well. So we don't have to, because you have a risk versus result ratio, and if the risk is going to be worse than the safety, then you shouldn't take it up. So it was great. It was going to be a question, but got to do a comment.
So I'll just make one quick comment on this 737 MAX incident, right? Two of them which happened within a gap of 4
Hawaiian
months,
Air, yeah.
right? Indonesia and Ethiopian Airlines. So MCAS was a system which was designed that, in case the aircraft is sensing a very high angle of attack, which was in manual flying, by the angle of attack sensor, and it was only dependent on the sensor from one angle of attack unit when there are two of them. So that particular angle of attack sensor, so what it does is, MCAS does is, when it's sensing that, it automatically
It's
pitches the
going
nose
down,
down.
it's gonna pull up.
And then that angle of attack sensor was not working. So the so the aircraft just went into, kept putting the nose
down,
down,
yeah.
and the pilot
Otherwise
was
it
trying to
stays,
recover,
yeah.
but they were not able to. And then ultimately it resulted in a fatal accident. So there were like two coins of thoughts that came from different facets of the industry. So there was this very famous aviation journalist back then who put the entire blame on the pilot, saying that because the industry has always been built, the aircrafts were designed and built in a way that, any kind of critical failure or multiple failures happen, you've been given your QRH or the checklist to, take care of them. And the pilot is supposed to take care of them based on the trainings we get, right? So you just go through the checklist items, and you should know, you should also know and remember which checklist that you have to refer to. The other side of the story were people like, I think a lot of you would know about Captain Sully. We've all watched the movie.
Yeah, Sully.
And he clearly said it's a
Sully
death
Bird.
trap.
Yeah.
Those were his words in the article. It's a death trap because the designers, the Boeing people, they didn't build redundancy into the system, and it's completely dependent on the pilots, taking a call on it. And I think Charlie Papa can further my comment.
I think those perspectives are all valid, right? When incidents happen, you gain a lot of perspectives. The Professor James Reason, proposed a model several years ago. It's called the Swiss cheese model. If you've seen Swiss cheese, you see holes in the cheese, right? When all the holes come together and they align, then you'll see an incident happen. It's never one thing on its own that causes an accident, right? Anywhere. It's a series of things that come together, perfect storm, then you'll absolutely have an incident happen. On that day, if you look at the entire history of that incident, or take the Cali-Columbia American Airlines 965 crash, or any one of these incidents, you will always observe in an accident report, if you let research flow through, you'll find several things came together at one time. The angle of attack sensor is one thing, the lack of an override capability is the second thing, training not being needed, the fact that Boeing said there's no more additional training required, people can fly because they've flown the prior 737, you can be fine. If you see the two, I have a picture on my phone with the engines of a 737-100 and a 737 MAX side by side. You can see where the engines were placed back in 1967 when the plane was born, and where the engine is positioned today. Same fuselage, extended, lengthened, and you can see the position of the engine, how far out in the front it's positioned. Right. When you, if ever you have a design to do, and if you try to offset fallacies in core hardware design through the use of software, you have a fundamental problem right there, right? You're compensating for a real problem by offsetting it with software and hoping it'll work, right? Absolutely. So you can see the multitude of factors just right now. We talked about 5 or 6. There are more, by the way. So when all of this comes together, then you'll see an incident happen. So any incident you go through, the Swiss cheese model always plays out. It doesn't have to be airplanes. You can, a car accident, if you fall outside tomorrow, right. A series of things came up. There's a piece of carpet that's jutting out by the bathroom. He was trying to glue it back together. If somebody isn't observing, if they're busy in a conversation and that carpet is sticking out, then you will fall, right? So you find that all of these situations, when you see perspectives come up, people are quick to react to what has happened. But adoption, if you ask me, I think should be slow regardless, so you can test it. Now, if you wait too long, you may miss the boat. You may, economically, fiscally, it may not be viable. Profitability is key, and everybody wants to be profiting. So that's why they create these designs. So one of the things that was said about Boeing was they were too much in a hurry to put the plane out there. Yeah. Airbus was coming up, they wanted to compete, so we positioned the plane. Never one reason. It's easy to come to these conclusions, but it's never ever one reason that comes together. So it's a fine point you make. Adoption needs to be, it should be timely and absorbed at a pace when risk is mitigated. I'll close on this point. There's a study recently about customer acceptance. passenger acceptance of any kind of technology anywhere inside the ecosystem of aviation. And the study was conducted by the University of Embry-Riddle, and then Scott Winter and Amy Hill put the study together. And you'll find that we ask people, would you fly on an autonomous airplane which can land and take off and land on its own? You'll find 6 factors that they've come up with amongst 530 participants, and they name out exactly the reasons why urban air mobility, we're talking of air taxis, right? You can land off the rooftops of a building and take you wherever, right? You've seen those videos on Airbus. And the acceptance levels are never what we can design. The acceptance level are you willing to fly if you knew there's nobody in the front of the cockpit there, it's empty, and you're all sitting in the back there hoping it's going to go someplace and land on its own. It may have the capability. Will you fly? If one incident could make people think twice about getting on board the MAX, how likely is anyone going to be when you know there's nobody in the front and you're going to sit there and watch this thing go up and land on its own? Without the human in the loop, as we call it, quote unquote, the human in the loop, it's almost, at this point in time, unviable. It's not comprehensible to believe that autonomous aircraft are here, especially with what she said, with increasing traffic, with drones in the sky, with urban air taxis coming up, air mobility changing hands, drone delivery by Flipkart or Amazon or whoever, all these units taking the same airspace that you're going to be flying in. We are having a hard enough time with regulating drones from coming in the way of modern aircraft, right? Everybody's complaining. Too many drone operators, drones are up in the sky on landing and final approaches, posing risks to aircraft. So if we can't handle that, I think fully autonomous capability may exist technically, but is it something that people would accept? Acceptance levels right now are low. I'm glad it is low, because at least that forces us, technicians, not to put technology out there too fast for them to absorb or adopt.
Very impressive. Fascinating response. Thank you so much.
Great question. Thank you.
Thank you, everyone.
Any other questions?
We have one more question. We'll have the mic passed, yeah.
You're out of time, right? Yeah.
Thanks much for the insights, sir. So as you touched upon the point that to bring any invention, or for that matter, to bring AI into the onboard avionics is going to be much tougher these days, because we have to do the STZs and we have to do TSOs, and the regulatory bodies are going to be, it's going to be tough. So we brought all those data to the off-board avionics, and we brought in all those AI into that aspects of iPad and other stuffs. That you also said that it is much more now in a distractive mode than in a more constructive mode. And your heads down time is also not going to get reduced. So what are those areas where we can dwell deep and understand, which can help you in bringing more kind of situational awareness when you are, as a pilot, when you are driving the flight, and also could reduce your distraction and could reduce your heads down time?
I think as humans, we have a limit on what we can remember. If you notice air traffic control communications, we break them down into 6 parts, 5 parts, or 7 parts at best. The normal human capability, you can take 4 things at any point in time. Research shows any beyond 7, you can't remember. If I tell you, descend and maintain 6,000, turn right heading 260, that's all you can do. And if I gave you additional runway instructions as an air traffic controller, you'll have a hard time. That's why they break instructions down, because your capability to absorb it, retain it, and act on it while repeating it back to the controller is too much to do. So assistive AI, I think, is absolutely viable, right? Ensley's research on situational awareness actually guides this whole notion of how much tech where, so that it doesn't become distracting, but becomes more of an awareness item, right? There is a limit to that. Even the very things we believe are assistive, an iPad in the cockpit, can prove to be distracting if it failed. So the question of how much, I think, is a combination of 2 things. What do we want to supply within the cockpit? But how do we then build the discipline in pilots to make sure we don't get so distracted by it? That's totally dependent on the individual exercising self-control. It's hardly about what you have on board. So limiting technology, I don't think, is the answer, because you got to test it. At the same time, building the resilience in the human mind to say, I won't take care of this now, I'm going to come back, land and handle this, I'm going to still continue to fly. That discipline is what has become an issue today, because we're all so distracted anyway. I mean, these phones are here to distract us all the time. So distraction is the primary issue we are challenged with. I think as long as something is assistive, And so long as it's not taken away from your ability to comprehend and act on it, I think you're still okay. That's where the curves actually intersect. Beyond that point, it starts to position risk. But you're right about certification and all that. And I'm glad it takes that long, to be honest with you. It's almost an insurance of some kind that it takes that long. Otherwise, we technicians would be putting technology into the cockpit almost every day and hoping we can upload new software into the cockpit like we do into a Tesla, right? We don't want the airplane having new software every morning, in fact. So it's all right for supplemental devices to fail. That's a human-in-the-loop problem. But building assistance to enable awareness, situational awareness, such as synthetic vision. Night landings, and you can't see anything outside, fog, you can't see anything outside. To have synthetic vision come up on your display and demonstrate the runway, totally, computer vision is a beautiful concept. It allows you to do things you could never do. You could see where you can't see. So things like that, I think, are still helpful. Challenge will be the day that fails. She and I have talked about it. Can pilots really even then fly? They're so used to it now. Have they forgotten how to fly? It's a common question in aviation. As long as they can keep the skill alive, and it doesn't lead to degradation of skills, which was one of my questions to her, which I never got to ask her. How much automation at some point then leads to skill degradation, that I can't fly anymore because I'm so used to these devices being there, the day it fails, can I still fly? And the answer today is, perhaps, perhaps not.
Thanks, Mish.
Sure. Thank you. Thank you so much to both of you for your patience and sharing your knowledge to all the members out here. I would like to welcome Mr. Venkatachalapati to kindly join us on the dais to present a memento and thanksgiving to CP Jois and Divya Manchanda. Thank you so much. We'll have one at a time forward. Let's take a picture. And can we have their goodie bags? Thank you so much, ma'am, and thank you so much, sir. And thank you so much, Mr. Venkatachalapati, for doing the honors. We'll have a hostess to help you with the baggage, sir. No worries. Yeah, thank you. So once again, we'd like to thank the audience for your patience, and I hope you had a great insight being today from the morning till now. Looking forward to see you all tomorrow. Our sessions would start from about 9:45 a.m. So request all of you to be here by about 9:30 a.m. That should be fine. Yep. I'll see you all around here tomorrow in the morning. Thank you so much and have a great evening. Thank you. Have a good day. Bye.